Hello. Good afternoon. Why is it so damn cold here? My name is Barry Dorrans. I am the .NET Security Curmudgeon. For those of you that don't know what that old English word means, it means a very grumpy old person that complains a lot, which is perfect for security because my entire job is complaining a lot, usually at David Fowler. My main job is to look at features, see what people are doing, and try and spot vulnerabilities before they're fixed, and then someone else can fix them. Or I own certain features even though I don't particularly want to, like ASP.NET Identity and a bunch of the security middleware. I also deal with MSRC when things go horribly wrong. And that's what this talk is about, things that went horribly wrong. And if you want to follow me on Twitter, I'm at Lodart. It is very sweary, it is very sarcastic, it is very cynical, it is very British. It's not very work-related. And a picture of the dog. So, I'm going to go through 9 MSRC cases and then one advisory, which is not an MSRC case, but will affect you anyway. I'm not going to talk about the basic things, although there are a couple of OWASP incidents towards the end. I want to talk about things that are more esoteric, things that you might think you're doing right, but you're probably not. Things that we discovered in our own code that will affect you and your implementations. Basically, I want to scare people, because it's fun. So the way the bulletin process works is someone will email secure@microsoft.com. They try and figure out whether it's a real vulnerability report or not, or if it's just someone being silly. And they will forward it to, they'll open a case in their Dynamics database. Anyone that's used Dynamics knows how horrible that is going to be. And then they email the product group security person, which is me for .NET. And then I look at the report that the sender has given us, and I try and understand it, and then I try and reproduce the problem. And sometimes I can reproduce the problem, sometimes I can't. If I can't, an email goes back via MSRC to the sender saying we can't reproduce this, here's what we've tried, please tell us what you did, because sometimes people don't. And then we try and reproduce it against all the supported operating systems and software configurations. So if I've got something in .NET Core, we'll test it against .NET Core 2.2. We'll also test it against 3 at the minute. 2.2, 2.1, 1.1, 1.0. And then if it's in classes that are in the .NET framework, it'll go all the way down from there. It'll go to .NET 4.8, .NET 4.72, I think, 7.1, 7.0, 4.6. We skip over 4 because that's not supported anymore, and 3.5. This takes a long time. And then sometimes it's language orientated, so then I have to start doing it in multiple languages, not just against the American format, but doing it against German or Turkish or Swedish, because you people have weird dots in weird places. And that can affect things. People make assumptions, which makes the process even longer. Sometimes it's easy, sometimes it takes a day, sometimes it takes 2 to 3 weeks to try and get a supported reproduction. And then I go find who's responsible for that area of code, which may not have been the original author, so someone else gets to deal with the mess. I say, here's the problem, please go away and fix it. And then I have to beat up their managers to say, no, they can't work in other things, they're going to work in this fix for now. And usually fixes are quick. Fixes may take 1 to 2 days. The longest one I've seen, though, took 6 months, and that was a nightmare because of all sorts of compatibility reasons. And then we test the fix. Now look, I realize a lot of you don't believe we test our fixes. Because when you apply them, they break things. We do, honestly. We go through the same test that we've done for the reproductions. Then I write a bulletin that's used for instructions because we deploy the fix internally across all of Microsoft's desktops and some of the Azure servers. And then we sit and we wait for a couple of weeks to see if anything is broken there, because we have a metric ton of telemetry turned on all of these things that never gets turned on in consumer machines. And then we give the fix to a bunch of early adopters who want to test it against their software. Those are external partner companies that have signed really, really bad NDAs that involve giving us their firstborn if they leak the software. It's large consultancies, it's large banks, people that want to know in advance whether they're going to have something to break. They get a simplified set of instructions that basically says, apply the patch, run your website, log in, did it work? Yes, good, we haven't broken you, because we can't give away what the problem is. And then finally, on Patch Tuesday at 10 AM Redmond time, a button is hit. The bulletin is released, is made available, and hopefully everything else has gone live around it. So the links on the .NET Core download site, or patches on Microsoft and Windows Update, and things like that. And then I sit back and wait for someone to tell me it broke. The next day there's a conference call with a bunch of CTOs from big important companies who want to ask questions about it, but I hardly ever get .NET questions, so I just sit there and I eat the free bacon. So, here's where, was someone laughing at free bacon? Wow, okay. So here's what I'm going to go through. Here are the security bulletins I'm going to go through one by one, along with their CVE numbers. If you're really bored and you want to look it up. Don't, it's really boring. Denial of service against hash tables. So this was a denial of service where someone looked at the hash function that we use in the .NET Dictionary object and pre-calculated a bunch of colliding hashes and completely screwed us over. We had a quick fix, which was limiting the amount of items that we could put in a dictionary that was sourced from ASP.NET, because ASP.NET takes headers, form, fields, query strings, and there's one other that's, oh, server variables, and puts those all in hash tables that are made available to every request. So you could just create a form with a bunch of pre-calculated hash values and just denial of service on ASP.NET site. So I can sort of like explain this a little bit if I talk about cats. Now, I'm a dog person, so I have no problem about abusing cats in my example. If you're a cat person, you're wrong, and you really should think about changing that. When you go on holiday, you as a cat person will probably, well, okay, our neighbor leaves their cat with us, which annoys my dog immensely. But some people will put their cat into boarding houses, cat hotels. I don't know what the Swedish word is, but I'm sure it is very long, and it has dots over things. So, the owner of this cat hotel has to have a way of classifying the cats to make it easy to return the right cat to the right person. This is our hash function in a dictionary. So, as a simple example, someone comes in and says, this is my cat Alphonse. He's going to take the first letter of Alphonse and put Alphonse in the A room. Then someone comes in and says, my cat's name is Bertrand. Bertrand goes in the B room, and so on. So we have a hash function. We're simplifying the actual name into something that we can use for quicker lookups. And once we get to quicker lookups, then we look through the individual items to find the right thing. This is how a hash table works. Now you can go interview Google. And then you come back and says, hi, I would like my cat Alphonse. So he goes to the A room and he picks up cat number 1 and says, is this Alphonse? No. Is this Alphonse? Is this Alphonse? And so on until you hit Alphonse. So in this case, what the attacker does is he gets a bag of 1 million cats. And he goes to the cat boarding house and says, here are my cats, please board them. And you look at this bag of cats that's squirming and hissing and scratching. And you go, okay, what are their names? Alphonse. Every single one of them. So you take the 1 million cats and you start pushing them into the A room. And the A room is going to run out of size, and it's going to take more and more time to squeeze these 1 million cats in, and the room may have to resize itself magically because it's a TARDIS or whatever. And that takes time. And so eventually we're increasing the amount of time it takes to insert. And that's bad enough. But then the attacker comes back the next day and says, give me Alphonse. And you go into the A room and you reach your arm in, and your arm is immediately scratched because 1 million cats in a room is not a happy bunch of cats. And you pick out a cat and you go, is this Alphonse? No. So you put him down. You go and pick up 2 of 1 million. Is this Alphonse? No. And you know where this is going. Alphonse is going to be the millionth cat that you pull out of the room. And that's your denial of service, because pulling 1 million cats out takes an awfully long time. So that is how hash collisions work. And this was great because it would bring down an ASP.NET it would bring down one processor for each thread this was running on, and you would quickly exhaust all the threads in an ASP.NET website, and then IIS would go, this website is hung, and kill it. It would restart, You do exactly the same thing with one or two requests, killed, and after the third time it doesn't get restarted again because we're not stupid. There is obviously a problem. So this was originally presented at the Chaos Communications Congress, which is a conference that is just after Christmas, where the attendees tend not to warn the people they're about to make very miserable over Christmas of what's coming up. And it was presented against PHP, Java, Python, and JavaScript. And then some smartass decided to port it to C#. So the best fix that we had, and the fix that's in .NET Core and that you can optionally opt into in .NET Framework, but it's optional because you people apparently like back compatibility over security. We told you, by the way, that get hashcode may not return consistent values from one run to the next, but then when we fixed this, we found that major banks were saving the hashcode away, despite the documentation, because no one reads documentation, hence it being optional. .NET Core, I was allowed to break it, I don't care. So we changed the implementation of get hashcode. And when a process starts up, a static value is generated and it is merged into get hashcode. So the value is unique for that process. So you have two processes running side by side. You call get hashcode on Alphonse, it's going to be different. So you're putting the cats into effectively different rooms each time. So you can't pre-calculate what the collision values are going to be. So how many of you have overridden get hashcode in your classes? How many of those classes go into dictionaries? There's more of you than that, and I know there is. So you now have a problem. And I will show you how this works. You will see my stunning demonstration skills. Because as I moved to being a PM rather than a dev, they extract all your dev credentials out through the ears and you forget how to program. So all my demos are nicely simple. Here we have a demo. So I have a good hash code that's going to be a string that's going to be inserted into a dictionary 1 million times. And then I have a really dumb instance of string which actually has a fixed hash code. So everything collides, it doesn't matter. And that's going to take an awfully long time. I used to run this on a Surface 3, and you could put your hand here and you could feel the processor getting hotter and hotter, and you could hear the fan kick on after about a second of starting to insert the bad hash codes. And I never wanted to leave it because I was worried that my machine was going to overheat and shut down, and that's super embarrassing in the middle of a demo, so I'll stop. So, the way you fix this is for the people that have overridden get hashcode in your classes, if those classes are not constructed solely from user input, you're good, usually. If you are constructing it from user input, you should change your get hashcode implementation so you have a static seed that is set, static for the class, so it's set to a random value when the class first instantiates. And your hashcode implementation should be changed. So it uses this static seed as part of the hash generation. SHA-1 HMAC is a good way to do this. The one that we use internally is called Marvin32, which is in our source for .NET Core, but is sealed because when we were using it in .NET Framework, it was just being written about in someone's PhD paper. But you want a hash algorithm that is resistant to collision. Resistant, it's impossible to have hash algorithms that don't collide, but you want to be as resistant as possible. Then we have panning Oracle attacks, which has nothing to do with the database. I assume a lot of you are going to use encryption in your applications, and you are all happy that you have implemented encryption correctly, right? Of course you are. The one person that has actually written a horrible SAML2 protocol for encryption says no, and he's probably the person I believe. But he makes me unhappy because he's keeping web forms alive with his code, and that's a whole other problem. Alright, so this is a web forms vulnerability, so you are keeping this nonsense alive. There was a handler in web forms called scriptresource.axd. It was supposed to serve JavaScript out of embedded resources. And you would ask it by just passing a parameter to it. I cannot honestly remember what the parameter name was anymore. And this endpoint was a bit dumb. You see, we encrypted the file name. So you could request something server-side and it would go to the client. The client couldn't work out where it was and we were all good and we thought that was good enough at the time. It wasn't. Because if you fiddled with the encryption, you could get a response back, well, you would get an exception back that would say this is an invalid string. And the way that encryption works, specifically block encryption works, this allows for an oracle and allows someone to work backwards to create a valid encrypted string without knowing the key, which is fun. So someone worked out how to get the encrypted version of web.config, fed it into scriptresource.axd, which was only supposed to serve up JavaScript, but no one had actually written those if statements. And so web.config was then servable. And for those of you that remember your old days, web.config includes things like connection strings, which of course have your username as SA and a password as something you thought was strong, because no one ever wants to use anything other than SA because leaf privilege is a pain in the ass. They also had machine keys in there, if you had set one of those, and those machine keys were used for a bunch of stuff, including encrypting and protecting ViewState and encrypting and protecting your authentication cookies. So once you have that machine key, I can recreate a valid authentication cookie for your website that says I'm admin. So that's nice. This caused a bit of a panic. This was back when Scott Goo was closer to ASP.NET, so he was involved in this one. This was before I took my role. So, if you want to talk about if you want to read about side channel attacks, they're really heavy in mathematics. The first one was in 2002 against SSL, because that's not a problem, and IPsec. And then someone decided, 9 years later, that they would expand it out to ASP.NET. Yeah, we had some warning of this. We got it patched before their presentation. They obviously demoed with a non-patched version, but it was still quite a big deal. So how do we fix this? Well, we don't expose padding oracles. We don't have this thing that says, yes, this is valid encryption, or no, this is bogus. We don't return detailed errors because a detailed error takes longer to calculate and display, so that in itself is an oracle because you can detect the difference in the length of time sometimes. And you just return 1 or 0 to indicate status, and you don't write something dumb like scriptresource.axd and not limit it to scripts. SharePoint. I love SharePoint. SharePoint does really weird things with ASP.NET that we never expected anyone in their right mind would do. And also, if you look at SharePoint URLs and all the goods that are generated, they are obviously contributing to the heat death of the universe, and if we ever run out of goods, it is SharePoint's fault. Remote code execution via serialization. Remote code execution is what we generally consider the most horrible and scary thing ever. It is an everyone stops and everyone fixes this. And SharePoint did it by disabling an ASP.NET feature. So I talked about machine key. And I assume some of you have written load-balanced websites in the old stuff, and you've had to make machine key the same on every single site, on every single instance. Because if you don't, things go horribly wrong. And then you have to try and change machine key at the same time on every single site, and you can't do that, so then some requests go wrong. We kind of fixed this in ASP in Core, but people are still unhappy with what we did because I can't win. So SharePoint decided that balancing machine key was too hard for SharePoint administrators. They may be right. They know their customer base better than I do, but they disabled it by default. And inside web forms, we had this wonderful hidden field called ViewState. And ViewState is a serialized binary tree of objects. And we protected it by default by putting a cryptographic signature on the end. So if you twiddled with it, we would reject it and we didn't do anything with it. But if you turn ViewState back off, you can twiddle with it all you want. You can replace it and it will accept it. It will deserialize, and then it just sort of like gets really bad. So, there are certain classes in the .NET framework that are marked serializable that really shouldn't have been, but back compatibility means I can fix it. One example of this is TempFileCollection. TempFileCollection is serializable, and like I say, we can put all these serializable classes in ViewState. So TempFileCollection you spin it up, you say, give me a new file name. You can use that new file name, and then when the class is disposed, it will delete all the file names. You can sort of see where I'm going with this. And because that's a property bag, you can set that in the serialized state. So if you create one of those with web.config as the only file name in it, serialize it correctly, shove it in ViewState, send it to SharePoint. SharePoint deserializes it. It's now got a temp file collection. When garbage collection eventually kicks that, your web.config is deleted and you've taken SharePoint offline. Which to me is a bonus. But the SharePoint people didn't see it like that. This is the only time I have ever gotten to introduce a breaking change patch into ASP.NET. It took me 9 months. Those 9 months were saying, hey, we're about to introduce a breaking change patch. Here is the patch. Why don't you go install it on some of your test machines and see if anything breaks? I have no idea if anyone ever did. Well, actually I have a pretty good idea, but I have no way to prove that no one ever did. And when we eventually pushed it out and made it mandatory, it only broke 3 people in the entire world that complained to Microsoft support. And those people were doing really weird things, to which my response was, you're doing really weird unsupported things, but here's how you can fix it for your weird scenario, but please don't do your scenario. So, we will have a ViewState. So, start a project, let's open the folder. Okay. So, what I will do is I'm basically going to write out a temp file collection with web.config. Well, I'm going to create a web.config. I'm going to write out a temp file collection with web.config. Then I'm going to deserialize it using Binary Formatter, which is the devil's formatter and should never be used. We'll talk more about that in a bit. But I don't want C# interactive, good lord. No. So we'll start this. Eventually what will happen is yet another one of my classy demos. So we can see we have web.config, and here's my fake ViewState. Let's go here. Okay, so we can just move that over so you can see I'm not cheating. I'm forcing garbage collection because no one wants to wait 5 minutes. But garbage collection has happened and my web.config is gone and SharePoint is down and the world cheers. I knew I get a cheer from American audiences for that because they hear the word cheer and think they have to do it because they're weird. That's why I like coming to Scandinavia, because no one asks questions. No one interacts. They'll sit there and chuckle, but no, don't bring attention to me. I mean, I've already asked if someone has, people have implemented get hash code, and that's about as far as I can go. So this went further. Despite SharePoint doing this when? 2013. Exchange didn't learn the lesson 5 years. 5 years later, binary formatter again. And this time it wasn't just deleting things. So there was an authenticated endpoint in Exchange Web Services. So you had to have an Exchange login, but that's pretty easy for a lot of things when you just sign up for Exchange Online. And it has a bunch of messaging interfaces for voicemail, and the voicemail is binary formatted data. So Docker also had the same problem. Docker's system service accepts instructions from the Docker systray or notification area application, which is run as your context. It sends things up to the Docker system service and it executes them. And it again used binary formatter. Even better, the communication was over named pipes. They did not ACL the named pipes. So from a really low privileged guest user, if it was enabled, you could call all the way up to system. and get system to do things, which is a really cool both remote code execution and escalation of privilege, because the only step above system is trusted installer. So, we'll show this as, here we go. I don't show you the creation for this one, because no. I'm just going to show you it being stupid. I'm going to take my payload, and then I'm going to call binary, I'm going to create binary formatter, and I'm going to deserialize this. So, no hands. PowerShell has started, which is not what I was expecting. Well, it's what I was expecting. It's doing something, it's downloaded things from the web, and it's downloaded the most horrific thing I could think of in Sweden.
Get that approved by corporate legal?
That one came off Wikipedia and is common criteria, but I don't care. I like this one. So, it's not just a matter of deleting files. Binary formatter is a horrible serializer, and you all need to go back to work, look at where you're using binary formatter, and cry, because it may well need changing. When you round trip state of things to a user-controlled space, you should sign it. And I don't mean sign it with a hash, I mean sign it with a cryptographic signature. So, SHA-1 HMAC, for example. And you don't publish your signing key like people did on GitHub. And you don't allow serialization formatters that allows an attacker to specify the object type. This is not just binary formatter, there are other things. There's a couple of projects that are on NuGet, there's JSON.NET. JSON.NET is, to be fair, secure by default, but there is a flag which is the type name handling flag, and if you set it to anything other than none, you're screwed. I like to call that the enable RCE flag, but James will not rename it for me. And he won't take it out because some people want it. .NET's JavaScript serializer, if you don't specify a type resolver, and the Net Data Contract serializer from 2012. If you're using serializers, when you call deserialize, if you cannot say, and this is the object type I want it to deserialize into, it is probably a bad serializer. Because if I can say in the serialized data, I am an object of this type, you have big problems. Okay, so look, if you are stuck with binary formatter, and you can't change your data format, this might work for you. We don't publish this in any help docs because we're not sure. We think there could be bypasses. Well, actually, it could be there's a remote possibility of out-of-memory exceptions with this, depending on some of the types that you use. We would rather see you have an out-of-memory exception on your website than remote code execution. So this is a use at your own risk. Do not email me about it. Do not ask for support. We have been thinking about ways to fix serialization and still keep back compat, and we're still mulling those over. It is a lot harder than you would think, especially when you still want to keep things compatible. How many of you use regular expressions? That's almost all the audience. How many of you use regular expressions for data validation? You're horrible people, because regular expressions are, and if you tell me that they're easy to read, you are drunk. I mean, I know Scandinavia drinks a lot, so some of you may think this. Regular expressions, and especially backtracking regular expressions, are horrible for validation, because with backtracking regular expressions, where you look at one character or a set of characters and then get a hit and move backwards, you can get those to take up not an infinite length of time, but an exponentially long length of time, if you can find the right crafted input. And someone had added regular expressions into data validators in .NET 4.5 or .NET 4.6. In .NET Core, there are a grand total of 3 regular expressions. One of those is one you set yourself, and the other 2 are in tests, because I called everything, and it made me really happy. So you can send this thing into a tailspin that will use an exponential length of time. It will eventually time out, but of course, if I send lots of these requests, you know, it may not have timed out, so then I take up a second CPU core, and a third, and a fourth, and a fifth, and then whack, comes down the IIS hammer. You sort of fix this by adding timeouts to all your regular expressions. For some unknown reason, when regular expressions were added to .NET, no one thought we should have a default timeout. That was dumb. So, infinite regular expressions. Would someone actually like to volunteer to convince me that regular expressions are a good thing? No, this is the whole picking on people in the Swedish audience. Because you see, if you were that volunteer, here is the regular expression for email validation. And it's not actually right either. There are a bunch of cases where it won't get it right now that we can have extended Unicode in user space. So I run this, and you know what happens with all of these demos now. It's just going to go horribly wrong. Here is a good value. Here is a bad value, and it's going to take a stupidly long length of time. And I can increase the length of time by adding, by extending the value that it's going to check against, which basically is a bunch of .t's. That regular expression comes from jQuery, which is fine because if you DOS yourself in jQuery, you are killing your own browser, and I don't care. So the way to fix this is stop using regular expressions. You're not as smart as you think you are, and everyone hates you. Or you set timeouts in all the regular expressions. In full .NET Framework, if you have a bunch of regular expressions that you can't immediately add timeouts to, you can set a global timeout by doing this. If you're in .NET Core, no, you have to fix all of them because you should know better by now. And then we have a couple really embarrassing ones that are digging down into the OWASP top 10 because, you know, sometimes the simple things are the best. I wrote this code originally, and when I wrote it, it was right. But the code that I wrote was not MVC enough. So when it was handed over to be put in the product, someone changed the code to be more idiomatic for MVC. And that was dumb. This was in two-factor authentication generation. And for the TOTP stuff that you have in your phone, that scan the barcode stuff. So that has a key in it. And that key value is just a bunch of numbers. And so when I wrote that bunch of numbers out to my code, I used HTML.raw because we had a double encoding problem at one point. And I knew that this was only going to be numbers. So I could use HTML.raw safely because I'm clever and I know better than all of you. Yeah, so using HTML.raw is kind of a red flag for your security reviews. And in this case, because I do the security reviews, my code was fine. And then, because I pulled the secret out of the database every single time, it wasn't round trip to user space. It wasn't part of the view model, and so there was no way for an attacker to control it. So it was honestly fine. But to make it more idiomatic, when it was translated into product code, it would get pulled from the database the first time and then shoved into ViewState, or not into ViewState, into the view model. And so it would get round trip to the client, so you could edit it on the client because it was HTML.raw. We could get XSS. So in .NET Core, review all your code for HTML.raw. If you do need to if you don't want to put things in the view model for going outwards, but you don't want them to be bindable, just apply the bind never attribute. And if something is generated server-side, you always generate it server-side and stop putting it in a hidden down field to transport it between requests because I got it right and they messed up. I mean, the important thing is I got it right. And we also have CSRF. I'll have a demo for that one. But we are running short in time, so we'll skip it. You know how this thing goes. I demo something, the vulnerability pops up. It's how it goes. So we also had CSRF. And again, this was right when I handed it over to the template people. There is, along with the multi-factor auth thing, there's the recovery codes concept, where you get a bunch of recovery codes, so if you don't have your phone on you, you can use a recovery code to log in. And those are generated once, and then if you can regenerate them and you can view them and so on and so forth. So because they were generated and weren't static, I did this as a post request. And when it turned into product code, they did it another way and it turned into a GET request, which means Well, in MVC we add the anti-forgery attribute to post requests by default, so no one can call it from another site. When they change it to a GET request, that protection goes away. So that means if you were browsing a bad site and it had an image link or some other link to the URL that generates the recovery codes on your site, it would just regenerate the recovery codes and the ones the user had stored would be wrong. Which was a bit of griefing. So, obviously, the spec says your GET should do something once and never actually affect it again. So resubmitting a GET shouldn't change the results, which was one of the things that the guys did. And when you change state, just basically use a post. And as with the last one, we don't let the people who optimize code for ASP.NET templates change my code, because it was right. Then we have WSDL. How many of you are still using SOAP? Yeah. Well, you deserve it, sir, because you write SAML2P. So this is your downfall. WSDL is metadata for SOAP endpoints. It's used to generate proxy objects, and then you try to skip all that nonsense by going to JSON, and then you got swagger because you decided to make the same mistake again. But that's a whole other PubConf talk. I didn't know this until it was reported, but .NET Framework, the old version of .NET Framework, have a WSDL parser built in for some unknown reason. And so, inside that is valid URL, and what the exploit was is, well, the way it works is it looks at the WSDL that's come in, it generates a .cs file, which is the proxy object, it writes it out into temp, it compiles that, and then it loads that newly compiled assembly into the memory of where the WSDL parser is. Great. Because automatically generating code, compiling it, and loading it into your own process is a really safe thing to do. This valid URL had a bug in it. It didn't parse comments and new lines correctly, so you could terminate a bunch of the checks and then just insert your own code in there. Whatever the hell you liked, as long as it was valid C#. So, an unknown nation state targeting Russian speakers in an Eastern European country that they had just invaded. Oh no. They used this to target the Russian speakers via a Word document, because Word has a certain way to activate COM, and the WSDL parser is a valid COM object, because you can use SOAP endpoints as data for mail merges or for tables. So they did something like created a table, pointed it to the WSDL parser. Didn't matter that it didn't go anywhere good, but the Word would kick off the .NET WSDL parser without telling the user. So there's no user interaction here. The WSDL parser is now compiling things in the background, compiles a bunch of C#, loads it back into the Word process, and lo and behold, we now have something that is perhaps authenticated to SharePoint or to Office 365 that can start emailing things out. So you can fix that by not being an enemy of Russia, which is kind of a problem. Or don't ever write code that generates code from user input, compiles and runs it, because that's really dumb. I still cannot figure out why that code was in the .NET framework. Then we have mistrusting user input. I am running out of time. This was a .NET Core one. URL helper contains a bunch of methods for generating URLs. Generally, those are all relative, but there is a way to generate absolute URLs where you don't tell us what the host header is. And the way we figure out the host header is we looked at the request object and believed what was on the request, which was silly. So that's controlled by the browser. And what Mikhail here did was, well, if you spoof the host header, it doesn't really matter because you're only spoofing yourself. But the password reset emails and templates use this to generate full URLs. So an attacker could generate password reset emails that were sent by the right server, because they're sent by your server and your email account, but have a completely different password reset URL inside. So a user could click and go to the right, or go to the wrong place. Because Kestrel didn't validate host headers at the time, because we thought he would do something done to host headers, you could actually embed HTML in it. We didn't care because we don't use them. But there are certain email clients would actually render this HTML, so you could actually write a form that would submit in certain email clients without user intervention. but not Outlook. Outlook actually did a good job with this. So you fix this by not listing it on the star host header. I know it's incredibly easy, but you should whitelist all your host headers. Limit them to the hosts of the ones that you know. And of course, validate your inputs. So now we do this in Kestrel. And the advisory. This is where we end up. Talked about padding Oracle attacks before, and how response times can be quite horrible. As an Oracle, it doesn't take a lot these days to actually start measuring response times from servers. And I have a demo for this somewhere. This is. I keep this one on OneDrive and not on GitHub. So I like giving this talk because you don't get any of the goodies. Conference presentations, global hacking vulnerability. Okay. You see, the problem here is languages that have exceptions. Languages that have exceptions take a long time to build an exception. And so the difference in that time is detectable, even over the internet these days, if you have a fast enough connection. And it's even more worrying if you have a determined attacker that gets themselves into the same cloud location as you. Because now they're an awful lot closer. There's still going to be little hops in and out, but they're not going out over the internet as a whole. They're going across all those fast backbone connections in your data center. So here we basically have now this sometimes works and sometimes doesn't because it's very padding dependent. Oh yeah. It's complaining because my font size is too big. I have to reduce it for this one. So this is taking a bunch of encrypted information and it is firing it against an endpoint. That basically is not going to return yes or no, or not going to return 1 or 0, it's just going to return the same damn thing every single time. But because the internal classes throw exceptions when padding is invalid, it takes slightly longer to return the same thing. And that can be detectable against, and we can start working backwards. Oh, it's working well today. And I'm decrypting something just by looking at the different response times. There's no yes or no's, it's always returning the same thing. And this was obviously written by an American because it's 4 years and 10, and they thought this would be funny for my demo. Because you know, this is when the Americans declared independence and became ungrateful colonists. So this is a problem with pretty much every language that throws exceptions in the way that you use encryption. So you fix this by always, when you were encrypting, adding an authenticated signature. It used to be that people said encryption was enough, and then we said, okay, what you do is you add a signature after the plain text data, and then you encrypt the whole thing, and then you can validate it afterwards. And now it's changed again. It's like we add an authenticated signature after encryption to the end, and we validate it. So in summary, sign your data even when it's encrypted. That one's really important if you don't want to get on the wrong side of GDPR, people. You don't use regular expressions. You sure as hell don't use binary formatter. It is horrible. You don't overbind an MVC, you use the right HTTP verb and validate your inputs. But if there are 2 things I want you to do, it is review your code for binary formatter instances and review your encryption code to make sure you are signing after you are encrypting. Whether you are storing that internally, or whether you are sending it to other people, or whether you're having it come back in, you need to have a signature and you need to validate that first. Otherwise you are exposing an Oracle and someone is going to decrypt your data once they get a hold of it. And that's pretty much it. I hope I scared some of you. I hope you at least go back and look at your encryption and your binary formatters. Thank you very much.